Okay, so hello everyone, welcome to all in YourPedia Education. My name is Manish Singh, and today I'm going to discuss with you one previous year exam question paper of HPCL exam. So as all of you, as we know that the HPCL notification already आ चुका है दोस्तों for 2023 recruitment drive, and as for this exam, you can see here the YourPedia team provides you a specific module for this exam, correct? And past 2 years से हम already ये session provide कर रहे हैं, and this is third consecutive year in which we provide this specific module for this exam. So let's see, before starting our this session, first we see what is this module, correct? Module क्या है and what are the things which is available in the module and how it helps you, correct? So let's see one by one. So in this module, we cover, you can see here, the coverage of all topics as per the syllabus for technical as well as non-technical. Both portion we cover here, correct? You can see. And similarly, you can see here the course duration for this module is 250 hours, and in which this duration includes both technical as well as non-technical portion. So if you feel any doubt, any query, then you just uh, chat box ke through you just tell me, correct? Yes, good evening Karthik. And now you can see in this model we provide you live classes as well as recording session. Yes or no? Live classes is provided here, as along with live classes we also provide you a recorded session, correct? And after every live classes, you can see after every live classes all the lectures are recorded, and whenever you feel you need to revise those lectures, then you can easily access, correct? And this model is available for 1 year. Validity of this model is 1 year, and one to one, you can say individual and combination of written as well as interview. Here we provide you a module for written exam as well as a module for written as well as interview, correct? तो written के लिए individual module है and written plus interview के लिए भी module है, and you can join any module, correct, separately. And for live classes we provide you every day information through WhatsApp, and you can see after every live classes we provide you a PDF, correct, PDF of that lecture. And you can see here five mock test and 20 subject wise tests we also provide you. So this module is a very nice and well designed module which covers the entire things of this exam, correct, in which we provide you a theoretical as well as practice session uh, along with test series, correct? And now you can see the module component live classes. You can see once again live classes and online test series, practice questions, recorded sessions, and interviews also we provide you, and group task means, correct, GD and GT both we provide you, correct? And now you can see here we have two variants of this module. First one, that is exam preparation only, and second one, that is exam preparation with interview preparation. Yes or no? And the classes will be scheduled at the morning from 7 a.m. and at the evening 7 p.m. and another class is at 9 p.m. and in which we provide you live classes as well as recording classes. Yes or no? And our batch will start from 25th of August. So if you are planning to prepare for this exam, then this module definitely help you a lot. Sir, chemical engineering discipline questions which date will be taken. So you can visit to the website for this information, correct? Present right now I don't have any information for this. And you can see here in this HPCL exam actually what will we have. You can see general English plus language proficiency we provide you 20 hours classes, verbal and non-verbal reasoning classes 20 hours, quantitative and general aptitude 30 hours, and technical for mechanical, civil, electrical instrumentation, correct? Mechanical, civil, electrical and instrumentation. These four branches we provide you 170-hour session, correct, in which we cover complete technical domain. And now if I talk about the pricing of this module, so if you opt written plus interview and you are new students, then obviously you need to pay 4,750 rupees and very nominal fee, correct? This is very nominal fee. And if you are from old students, so you can see this the fees is 4,200 rupees. And only for written exam in which we cover technical as well as non-technical, then the fee will be 3,100 rupees and 2,650 for old students. And similarly, if you opt only for non-tech, then it will be a 1,299 rupees, and for old students same fees, correct? So this is all about fees. So now let's see. Obviously, in this session, I'm going to discuss with you all question from mechanical engineering, and this is a question paper from previous 2021 exam, first session. Yes or no? So let's see. Okay, so I hope it is visible to all. Hello. I hope it is visible to all, correct? So this is question number one, and along with me, you can also try to solve this question. Is it clear? और इस क्वेश्चन सीरीज के हेल्प से आपको पता चल जाएगा कि व्हाट स्टैंडर्ड्स एक्चुअली किस स्टैंडर्ड से क्वेश्चन पूछे जाते हैं एंड हाउ यू प्रिपेयर फॉर दिस एग्जाम. So you can see here the first question: a vibrating system consists of a mass of 200 kg, spring stiffness of 80 Newton per millimeter. Then the natural frequency of the vibration system is. So here you need to calculate natural frequency of the system. So how you calculate? So as you know that omega n is nothing but this is square root of k by m. This is very simple formula. Yes or no? This is very simple formula. Correct? So if you put these values on this formula, then you will get the answer. So what is K? Stiffness is already given here, that is 80 Newton per millimeter. First you need to convert this into Newton per meter. 80 Newton per meter. Is it clear? 80 Newton per meter. So it can be written as 80 into 10 to the power 3 Newton per meter instead of 80 Newton per millimeter. Yes or no? So this is 80 into 10 power 3. And what about mass? Mass is given here, that is 200 kg. So simply we can write 200. Now if you solve this equation, if you solve this, then you will get this is square root of 400, and which is nothing but this is 20 radian per second. 20 radian per second. So option 3 is the right choice. Option 3 is the right choice. Is it clear? Option 3 is the right choice. Sir, is aptitude question same for all discipline for the HPCL exam? Yes, yes. For all discipline, the non-tech portion is remains same. Okay, so now let's see another question. This is question number 2. The unbalanced vertical force which tends to slide one portion of the beam upward and downward is called as. So as you know, whenever we have a force which is acting parallel to the cross section of the beam, then can we say this is called as shear force? Yes or no? Can we say this is called as shear force? Yes or no? So you can see here, unbalanced vertical force which tends to slide one portion of the beam upward or downward. Correct? So let's suppose this is a beam, correct? And if I cut a section from it, is it clear? And suppose this is a simply supported beam. This is simply supported beam and it is subjected to a point load at its midspan. So if I draw its free body diagram about this cross section, so can I draw? It is looking like this. One force which is acting here, that is P by 2. Yes or no? Obviously, if I say this is a symmetrical loading, then reaction at the both end we have same value. Yes or no? And if I cut the section from here, this is x6, correct? And now if we draw its free body diagram, then obviously you know one force is acting like this, another force will also act here. Yes or no? And what about this force? So can I say this force is nothing but it is acting parallel to the cross section? Yes or no? And if it is sir, okay, blurry image shows. Okay, so let's see. So the correct answer is option C. Let me correct it. Okay, now it is visual. SK, tell me. Now it is visual properly. Hello, let me check. If I use higher quality images, okay, so tell me which one is the correct answer for question number 3? Anyone? Now it is visible to all. Tell me. So you can see, yes, now it is visible. So in the MIG welding process, a lot of spattering occurs when the shielding gas used is. Tell me which one is the right answer. This is very simple question. The correct answer is carbon dioxide gas. Carbon dioxide gas. The correct answer is carbon dioxide. Actually, we use CO2 gas for improving its you can say heat heat concentration, yes or no? Because with the organ we face one major difficulty, that is heat concentration with the organ gas is very low, yes or no? But in the case of helium we can get proper heat concentration, but its cost is very high. So instead of using helium we use organ gas, and for improving its heat concentration ability we can add CO2 gas with argon, yes or no? So generally we use mixed gas, argon with CO2. Is it clear? So the correct answer is CO2, but along with CO2 we get spattering, more spattering of the metal, yes or no? Okay, so next, long cast iron pipes of uniform thickness are manufactured by, tell me. Long cast iron pipe is manufactured, long cast iron pipe of uniform thickness are manufactured by, then obviously cast iron pipe is made by metal casting process, yes or no? Why? Because the castability of the cast iron is very excellent, yes or no? Very good. The castability of the cast iron is very good. Is it clear? So which method is suitable for making long cast iron pipe? Then obviously the answer is centrifugal. And if I tell you more precisely, then true centrifugal casting process will be used for making a long cast iron pipes, yes or no? So the correct answer is centrifugal casting, and if we see more precisely, then we can say true centrifugal casting, yes or no? True centrifugal casting. True centrifugal casting. Is it clear? True centrifugal casting. Okay, so let's see another question. And this is very familiar question. Many times it asks, in a reciprocating engine, the primary direct crank makes an angle theta with the line of stroke. Then the secondary direct crank will make an angle of. Correct? Tell me which one is the right answer? Which one is the right answer? Which one is the right answer? Anyone? So as you know that the centrifugal force in a reciprocating engine, correct? So if I write centrifugal force, so can I say this is nothing but it can be written as mr omega square, yes or no? Mr omega square into cos theta plus cos 2 theta by n, yes or no? Cos 2 theta by n, yes or no? Cos 2 theta by n, yes or no? Is it clear? Cos 2 theta by n. Is it clear? So this is our relation. So you can see here, if I break this expression in this form, mr omega square cos theta plus, we can say m 4 times of r, 4 times of r by 2n Okay, just say, once again I'm writing, the centrifugal force is nothing but, here we have this relation. Once again you can see here, Fc is equal to mr omega square cos theta plus cos 2 theta by n. Yes or no? Can I write like this? And similarly, if you break this, then here we can get mr omega square cos theta, yes or no, plus mr omega square cos 2 theta by n. Is it clear? So you can see this component is nothing but, this is called primary force, yes or no? This is called as primary centrifugal force. And what about this? This is called as secondary. This is called as secondary centrifugal force. Yes or no? Secondary centrifugal force. Yes or no? Tell me. Is it right? So this, if I write secondary centrifugal force here, so can I write, it can be written as m into 4r by n into 2 omega whole square, 2 omega whole square into cos 2 theta. Yes or no? Cos 2 theta. So let's see first one by one. So if I describe this part first, primary force. So obviously you have this system. Yes or no? Obviously you have this system. This is crank. Yes or no? And here we have a piston cylinder arrangement. Yes or no? Is that clear? So here we assume the whole mass of the piston is concentrated somewhere here. Yes or no? Which is situated at a distance of r, and it makes an angle from the horizontal, it makes an angle theta, and let's say if it rotates with omega. Yes or no? So the whole mass m is situated somewhere here, which will lie on at a distance of r with rotation of omega, and it is lie on at an angle theta. Yes or no? So simply here we have one force, that is mr omega square cos theta. Yes or no? Is it clear? Similarly, in similar way, can I represent secondary shear force? Sorry, secondary force. So this force is situated somewhere at angle theta, and this force is situated somewhere at an angle 2 theta. So can I say this point is lie on somewhere here? Yes or no? At an angle 2 theta, yes or no? And similarly, this mass, instead of this mass, the whole mass m is situated at a radius of 4r by n. Yes or no? So it will be lie on somewhere here. So this is the mass m, which is lie on at a radius of 4r by n. Yes or no? 4r by n. Is it clear? And it will rotate with 2 omega speed. Yes or no? It will rotate with 2 omega speed. So here we need to find out, in a reciprocating engine, the primary direct crank makes an angle theta with the line of action of the stroke. So this is line of action of the stroke, and it will make an angle theta. Then the secondary direct crank will make an angle of, so obviously you can see here, this is the secondary crank, which makes an angle 2 theta. From this formula you can see, from this formula, this is secondary force. Yes or no? This is secondary direct force. And if I represent this secondary direct force, so can I say the whole mass of the piston is situated somewhere here, that is m, at a distance of 4r by n. This is radius, which rotates with 2 omega speed, and the force is acting here with 2 m 4r by n 2 omega whole square cos 2 theta. Yes or no? Then the answer will be 2 theta. Yes or no? Then the answer will be 2 theta. So I hope you will understand what is primary and secondary force which is acting in the reciprocating system. Yes or no? Yes or no? Tell me if you have any doubt. Yes, n is L by R. Yes, correct. You are correct. Okay, so let's see another question. The preference of a steam cycle in a power plant is compared with a standard process of. So obviously we know that the power plant can works on Rankine cycle. Yes or no? Power plants works on Rankine cycle, and this is the cycle correct? This is the primary cycle, and nowadays we modified the Rankine cycle. Nowadays we using modified Rankine cycle, yes or no, which is called as either regenerated Rankine cycle or reheated Rankine cycle, or both regeneration and reheat is used in the Rankine cycle. So for the reference we always use Rankine cycle. This is the actual cycle on which the power plant can work, yes or no? This is the actual cycle. Carnot cycle is not the correct answer. Correct. This is a theoretical cycle. In no, none of the system can work on the Carnot cycle. Is it clear? And air standard cycle, obviously, on this cycle, uh, this is the reference for gas power cycle. Yes or no? This is the reference for gas power cycle. It may be Brayton cycle, it may be Otto cycle, it may be diesel cycle. Yes or no? And obviously, constant pressure cycle is not used. This is not a reference. Okay. So what about question number 7? At constant pressure, heat energy of 1800 joules supplied to 2 kg of fluid, which causes a rise in temperature of 15. You can see here the rise on the temperature is given here. So if I write, you can see the a constant pressure. This is a constant pressure process, and heat energy 1800 is supplied. So can I say Q is nothing but this is 1800 joule, and obviously this heat is supplied at constant pressure process when the pressure is constant. Correct? And the mass of the fluid is 2 kg. Mass of the fluid is 2 kg, which causes the rise in temperature of 15 degrees centigrade. So delta T is nothing but this is 15 degrees centigrade. The average specific heat of the fluid, we need to find out specific heat of the fluid. So as you know that the heat supplied at constant pressure process is nothing but this is mcp delta T. So here we need to calculate Cp. So what about Cp? Cp is nothing but this is Q over m into delta T, and here you know the Q is given here, that is 1800 joule, and what about mass? This is 2, and what about delta T? This is 15. Is it clear? So what about the units? Yes, the all the things are given in joule, kg and degree centigrade. So this is joule, this is kg and degree centigrade. Yes or no? Now if you solve this, then you will get this is 900, and this is 6. 60, yes or no? This is 60. So the correct answer is Cp is nothing but this is 60, 60, and the unit is joule per kg degree centigrade. 60 joule per kg degree centigrade. So correct answer is option C. Yes or no? The correct answer is option C. Okay, so let's see another problem. So this is memory based question. Correct? Sometimes these things you must remember. Okay, so you can see a Pelton wheel with a mean diameter D is the diameter of the wheel, has the jet diameter D. The number of buckets required for this impulse turbine is. So obviously you know that impulse turbine can be looking like this, yes or no? Over the periphery of this, here we have buckets, yes or no? In the periphery of this turbine we have buckets, and here we have a nozzle. Through this we can throw water, yes or no? This is nozzle. So this diameter is nothing but this is the diameter of the nozzle, and this diameter is nothing but this is the diameter of diameter of turbine, yes or no? Pelton wheel turbine. So we need to find out the number of buckets required for the impulse turbine is. So number of buckets, if it is represented by n, then it is nothing but it can be written as m plus 15, yes or no? The correct formula is n is equal to m plus 15, where m is nothing but it is the ratio. It is the ratio of m by 2 plus 15. So it is the m. What is the m? M is nothing but it is the ratio of capital D by small d. So simply we can write this is capital D by 2 times of small d plus 15. This is the answer. This is the answer. Correct. So this is the formula, n is equal to m by 2 plus 15, where is the m is the ratio of capital D by small d, where capital D is diameter of the bucket and small d is the diameter of nozzle. Yes or no? Yes or no? So the correct answer is option C. The correct answer is option C. Okay, so What about this? The weight, total weight of a body is an example of. So as you know that if I talk about force, so here we have two types of forces. First one is force by volume, force by volume, and another one that is force by surface area. Is it clear? So obviously force by volume is nothing but this is called as self weight. Is it clear? Self weight. And this is called as surface forces. इसको क्या बोलते हैं? This is called as surface forces or body forces. Sorry, surface forces, not body force. Surface forces. This is called body forces. Is it clear? This is called body force. This is called surface force. How? Let's say, suppose you have a beam like this, and these are the supports, and one force is acting externally. Yes or no? So can I say this external force is called as this force is called as surface force? Yes or no? Surface force, and this force is acting at a very small point. That's why it is called as concentrated force, and its own weight, this own weight, or we can say self weight. The self weight of this body is called as, this is called as body force. Body force, or we can say weight. So the correct answer is the total weight of the body is an example of volume force. Is that clear? So always remember we have two types of force, that is volume force and surface force. Volume force is also known as body force, and body force is nothing but this is weight due to own density, own mass. Yes or no? Is it clear? But the surface force always act externally. It may be distributive in nature or it may be concentrated in nature. If it is concentrated at a very small point, a small area, then this is called as concentrated load or point load. And if it is distributed uniformly throughout the length, then this is called as uniformly distributed load. And if it is distributed linear with linear variation, then this is called as linearly variable load. And if it is not a particular if it is not following any particular variation, then we can say simply variable load. Yes or no? So these are the types of different forces. Okay, so now you can see generally the bill of material, that is called as BOM. Is that clear? Bill of material, this is also named as BOM, does not consist of, bill of material does not consist of, tell me which one is the right answer. So bill of material bill of material tells us about the availability of the sub component. Yes or no? Let us suppose if you manufacture a car, so obviously car consists of thousands of parts like bearings, wheel, tire. Yes or no? Is it clear? And so many things, correct? So actually bill of material includes all subparts, their quantity, their location, yes or no, their availability, yes or no. So these things are mentioned in the bill of material, but never we mention that is price of the part. Yes or no? Price of the part is not mentioned in the bill of material. So correct answer is option B. Generally the bill of material not consist of, actually we need to find out not consist of. So bill of material never be consider price. Yes or no? So the correct answer is option 2. Okay, so what about this question? The fundamental property of material able to resist abrasion is called as, obviously the resistance against abrasion or scratch or indentation, this is called as hardness. Yes or no? This is called as hardness. So the correct answer is option 1. What about in TIG welding? The welding joint is shielded by an atmosphere of. In TIG welding means tungsten inert gas welding. In tungsten inert gas welding, which gas is mostly used for the shielding purpose? So the correct answer is, you can see, argon gas. Argon gas, this is the correct answer. Hydrogen gas is not used. Carbon dioxide is also used, but the mixture of argon and CO2, we never use pure CO2 gas. Yes or no? Yes, in some metal we can also use, but mostly in most of the welding we use argon gas. And the TIG welding is developed primarily for the welding of aluminum alloy. Aluminum alloy, yes or no? Is that clear? So aluminum alloy, as we know that this is very prone to react with oxide. Oxygen react makes oxides. So aluminum is a very reactive material which is reacting with oxygen and produces aluminum oxide, which is ceramic. Yes or no? So to prevent the formation of ceramic, to prevent the formation of oxides, we must provide a very huge, very good insulating environment, protecting environment, and which can be produced by argon gas in the TIG welding process. And obviously we can also use helium, but the cost of the helium is obviously very high. And now you can see 30 number, an ideal reciprocating air compression demands less work to run if the compression follows. If the compression follows. Anyone, can you tell me which one is the right answer? Which one is the right answer? Anyone? Okay, so the correct answer is isothermal process. Isothermal process consume very less. Isothermal process required very less work input for reciprocating compressor. Is it clear? Next question. The power transmitted through the pipe is maximum when the head loss due to the friction in the pipe is. So you can see if I write, so as you know that power is nothing but you can see here, if I write power is nothing but we can write this relation. This is rho g by 1000 into area, that is pi by 4 d square, into velocity into capital H minus HF. Yes or no? And HF is nothing but this is FLV square by 2GD. 2GD. Yes or no? So similarly here you get this relation rho g by 1000, rho g by 1000 into pi by 4 into d square into VH minus, if I use this term, so simply can I say uh, this is VH minus FL V cube by 2GD. This is the relation. So can I say this power is a function of velocity? So for getting maximum power, we must differentiate this expression with respect to velocity and put it equal to 0. And when you differentiate this expression with respect to velocity and put it equal to 0, then you will get this relation. HF. So here we need to find out the power transmitted through the pipe is maximum when the head loss due to the friction is. So HF is nothing but it can be written as this is H by 3. And where HF is nothing but this is friction loss, friction head loss, and H is the total head. Yes or no? H is the total head. Okay, so let's see another question. The hardness of the steel can be reduced considerably by the treatment process. So for the reduction of hardness, we provide annealing process. So what about normalizing and hardening process? So you can see normalizing is a process in which the material is heated up to a certain limit, in which the iron is present in the stable austenite form. Yes or no? And then it will cool into the atmospheric air. Then this is called as normalizing process, and through normalizing process the strength will be increases. Yes or no? Hardness will be increases. Is it clear? And we can say the toughness also increases. Is that clear? Similarly, if I talk about hardening, so hardening is a process in which the medium carbon steel is heated and then quenched into the water. Simply, you just dip this material into the water, then martensite transformation takes place. So, the main purpose of the hardening is to transform austenite into martensite. And as we know that martensite structure is one of the hardest. Martensite structure is the hardest phase of the iron. Yes or no? And it has very huge amount of brittleness. So obviously this is the wrong answer. And you can see normalizing and hardening, this is also wrong answer. So the correct answer is annealing process. And through annealing process we can reduce hardness. Yes or no? Through annealing process we can reduce hardness. correct? Okay, so let's see another question. In the nitriding process for steel to the harden the surface. So obviously in the nitriding process we use ammonia gas. In the nitriding process we use ammonia gas, and this nitrogen reacts with material, because some elements we have like vanadium and some more elements, uh, they can react with nitride. Nitrogen produces nitrides, and the nitrides formation of these elements is very high as compared to carbide. That's why those alloys are hardened by using nitriding process, not for carbidizing process. And in the nitriding process we use ammonia gas. And similarly, if I talk about carbidizing process, so here we have three types of carbidizing process, that is pack carbidizing, gas carbidizing, and liquid carbidizing. Yes or no? In the pack carbidizing, in which we use powder. And what powder? Charcoal. Actually we use charcoal, calcium carbonate. Yes or no? These powder are used for hardening purpose. Yes or no? Similarly, if I talk about liquid carbonizing process, then obviously here we use liquid cyanide, potassium cyanide, sodium cyanide. Yes or no? Correct? These are used for hardening purpose. And if I talk about gas carbonizing, then we use natural gas, just methane, ethane, propane. Yes or no? These gases are mainly used for gas carbonizing. And similarly in nitriding process we use ammonia gas. Yes or no? Okay, let's see another question. The concept of internal energy is discussed in. So obviously this is very simple question. The concept of energy is discussed on first law of thermodynamics. Second law of thermodynamics we deal with quality of energy, but a first law of thermodynamics deals with quantity of energy, how much internal energy, how much enthalpy is available in the system. And zeroth law of thermodynamics is basically based on a temperature measurement. And if I talk about third law of thermodynamics, so it is based on, it is impossible to make 0 degree centigrade temperature. So this is basically deal with this. Yes or no? So the energy concept is discussed in the first law of thermodynamics only. Okay, so let's see another question. A vehicle of mass 1200 kg is moving at a speed of 72 kilonewton, kilometer per hour. The amount of energy be absorbed by the brakes to stop the vehicle. So simply the braking energy absorbed is nothing but this is half of mv square, that is kinetic energy. This is kinetic energy, since there is no potential energy. Otherwise we use sum of potential energy and kinetic energy. Yes or no? Braking energy plus kinetic energy is equal to potential energy. But yes, this is moving in the same plane. So here I am using only kinetic energy. So simply you write this is half of m. And what about m? This is 1200 mass. And what about speed? This is 12 kilometers. So can I convert this into meter? And similarly, hours is converted into seconds. So simply we divide 3600 second. Yes or no? Now if you simplify, then you will get 240 kilojoule. Is it clear? So this is very simple question again. And another question you can see, a simply supported beam of span 4 meter and I, that is 12 into 10 power 6 millimeter to the power 4, is subjected to a central load of 9 kilonewton. The deflection of the beam when the Young's modulus is 200 GPa. So you can see here the moment of inertia is given, that is 12 into 10 to the power 6 mm to the power 4, and the load, external load, is this is concentrated load which is acting at the center, that is 9 kilonewton. So simply can I write this is 9000 newton. And what about Young's modulus? This is also given here 200 GPa. So this is 200 into 10 power 3 megapascal. Yes or no? So here we need to find out uh, deflection. So as you know, this is simply supported beam and the load is acting at the mid span. So for this, if I write the maximum deflection, so it can be written as PL cube over 48 EI. Yes or no? And if we put these values on this formula, then you will get the answer. So simply here P is nothing but this is 9000 Newton into length is given, that is how much, 4 meters. So can I say this is 4000 millimeter cube over 48 into E is given, and what about is that is 200 GPa, so 200 into 10 power 3, and moment of inertia is also given, that is 12 into 10 to the power 6. Now if you simplify this, then you will get 5 millimeter. After simplifying this, you will get 5 millimeter. Yes or no? Yes or no? So let's see another question. The absolute temperature K scale needs only one fixed point. Which is the name of that point? So the correct answer is triple point. The correct answer is triple point. Correct. So for Kelvin scale, we use only one reference point, that is triple point. A triple point is a point at which the sublimation, correct, vaporization and means liquid, solid and gases, three, all these three phases are coexist. Yes or no? This is called as triple point. Yes or no? Okay, so next question, you can see the transfer of heat from one part of substance to another by lattice vibration is called. So obviously in the due to the lattice vibration, the heat transfer takes place. This is called as conduction. This is called as conduction. Yes or no? This is called as conduction. Is it clear? So obviously due to lattice transfer, the heat is only the mode of heat transfer is called as conduction. And through conduction, the heat is also transferred through free electrons. Yes or no? And mostly this is happens in the metal, and the lattice vibration happens in the non-metals. Yes or no? Is it clear? So in the non-metal, the reason behind conductive heat transfer is lattice vibration. Yes or no? Okay, so let's see another question. The strain energy stored in the body due to the external load is known as. So strain energy stored in the body is known as resilience, or simply we can say strain energy. And what about proof resilience? So you can see here, if I draw a stress versus strain diagram like this, so and if I say this is elastic limit, this is elastic limit. So whatever is energy stored in the elastic limit, energy stored in the body when it is subjected to an external load, then this is called as resilience. Correct? This is called as resilience. And how we represent this? So simply you can say strain energy is nothing but this is work done. And if I draw load versus displacement curve, so simply can I write this is nothing but this is half into delta. Yes or no? So if I write strain energy, so can I say this is nothing but if I divide with original area and also divide with original length, then we need to multiply this area and length. So simply here we can get strain energy is nothing but half of sigma into strain into volume. This is called as strain energy, which is stored in the body when it is subjected to an external load. So don't be confused with this modulus of resilience. Correct? And this is also called, if this energy is stored within the elastic limit, then can I say this is called as resilience. This is called as resilience. If this energy is stored in the body within the elastic limit, this is called as resilience. And if this energy is stored up to elastic limit, means maximum strain energy, correct? Maximum strain energy, correct? So this is called as proof resilience. What is proof resilience? That the maximum strain energy up to elastic limit into strain up to elastic limit into volume. Yes or no? This is called as proof resilience. And similarly, if I talk about modulus of resilience, then modulus of resilience is nothing but this is proof resilience per unit of volume. This is called as modulus of resilience. Yes or no? So what about this? Which one is the correct answer? So you don't miss this point, because we calculate strain energy from this. Yes or no? And why it has happened? Due to the external load. Yes or no? When the member is subjected to external load, then the strain energy will be stored, and strain energy can be represented like this, that is half of sigma into epsilon into volume. And if this energy is stored within the elastic limit, then simply we can say resilience. And if it is maximum limit, suppose this is called maximum, so this is called as proof resilience. This is called as proof resilience. Yes or no? This is the maximum limit. Within the elastic limit, then you can say resilience. If it is maximum limit, then this is called as proof resilience. And if you represent proof resilience per unit volume, then this is called as modulus of resilience. And this is also called as strain energy density. Whenever you represent strain energy per unit volume, then this is also called as strain energy density. Is it clear? Okay, so let's see another question. The moment of inertia about x-axis of a hollow rectangular section. So simply you can see here, suppose we have a hollow rectangular section like this. This is hollow rectangular section in which we have material somewhere here only. Yes or no? And the moment of inertia about xx, let's say this is xx axis. For a hollow rectangular section with the external dimension breadth is given, this is 6 mm, and height is given, that is 8 mm, and the internal dimension breadth is 3 mm, and 4 mm is height, this is internal dimension, respectively is. So can I say the moment of inertia of about this xx is nothing but, if I assume the whole cross section, अगर मैं सारा का सारा cross section assume करूं, then the moment of inertia of this rectangle is nothing but, can I say this is half of 6 into 8 cube over 12, sorry, 6 into 8 cube over 12. And how I am writing this expression? So simply you see, whenever we calculate moment of inertia of any axis, जिस भी axis के about आपको moment of inertia निकालना है, उस axis को देखो किस dimension को कट कर रहा है, जिसको कट करे उसी का क्यूब करना है. And similarly you can see here in this x axis may cut this depth only. That's why here I am putting this d cube. Yes or no? Correct. So this is the moment of inertia of whole rectangle, but the internal part, this part is not available here, this is hollow section, so we need to subtract this part. So can I say this is nothing but this is 3 into 4 cube over 12? Yes or no? Now if you simplify this expression, then you will get option 1. Option 1, this is the right answer. Is it clear? Okay, so let's see another question. That is question number 24. That is the algebraic difference between the maximum limit and the basic size is called as the algebraic difference. You can see here. If I say this is the basic size, this is basic size. Yes or no? So, and if you have a hole whose tolerance is looking like this is the tolerance zone. Yes or no in the hole? So this is called as lower deviation. This is called as lower deviation. You can say, suppose you have a hole like this, you have a hole like this. Yes or no? And this is basic size. Yes or no? So can I say this is called as minimum size? Yeah, minimum limit. Yes or no? This is a minimum limit and this is maximum limit. Yes or no? This is called as maximum limit. Yes or no? Is it clear? Maximum limit. So the difference between minimum limit and basic size is called as lower deviation, and the difference between maximum size and basic size is called as upper deviation. Upper deviation. Yes or no? So the correct answer is upper deviation. Correct answer is upper deviation. Yes or no? So anybody tell me, if you have any doubt, then you just ask me. Correct? कभी भी कुछ भी डाउट लगे, you just ask me. Is it clear? Okay, so let's see another question. The allowances for the liquid shrinkage is considered in a design casting pattern. The reduction in the volume of cast metal occurs during. So, as you know that in the metal casting process, you can see the raw material always present in the form of solid. Yes or no? This is solid metal. And can we say this is raw material? Yes or no? Which is used for casting? Yes or no? So first this raw material is heated, this is heated and converted into liquid metal. And when you convert from solid to liquid metal, then obviously expansion takes place. Suppose its volume is V1, its volume is V2. So can I say this V2 is nothing but this is V1 plus delta V? Yes or no? Is it clear? This is right? Yes or no? Now, if you pour this molten metal again in the mold cavity, this is, let's say, this is mold cavity. This is mold cavity. If you pour this molten metal into the mold cavity, then during solidification from liquid to solid, the volume gets reduces. Let's say this is V3. So can I say this is V3 is nothing but this is V2. This V3 is nothing but this is called V2 minus delta V. Some amount of the material, some volume of the material get shrinked. Yes or no? Some amount the volume of the material get shrink. Yes or no? Is that clear? So in this question we have the allowances for the liquid shrinkage, allowances for the liquid shrinkage. You can say this is liquid shrinkage. And one more thing, if I draw cooling curve, then simply you can see it is looking like this. It is looking like this. Yes or no? This is cooling curve, this is temperature, and this is time. Is it clear? And this is called as liquid shrinkage. Yes or no? This is called as liquid shrinkage in the casting. Yes or no? This is called as liquid shrinkage, and this is called as solidification. This is called as solidification, and this is called as solid shrinkage. Is it clear? This is called as solid shrinkage. Is it clear? So you can see the allowances for the liquid shrinkage is considered in the design casting pattern. The reduction in the volume of the cast metal occurs during cooling of liquid metal to solid metal. Obviously, you can see here from this, the first initially its temperature goes decreases from pouring temperature. This is pouring temperature, and this is freezing temperature. Yes or no? And this is room temperature. Is it clear? When you cool the material from pouring temperature to freezing temperature, then the entire shrinkage takes place in the liquid state. Yes or no? This is called as liquid shrinkage. And after that, you can see in this at constant temperature, the phase transformation takes place. Yes or no? This is called as solidification shrinkage. Again, here the volume is decreases. Yes or no? Is it clear? And after that, we have this is solid shrinkage, in which the solid metal gets cooled from freezing temperature to room temperature, and the entire shrinkage takes place in the solid state. So first two shrinkages are compensated by riser design, and the third one is compensated by pattern design. So this is all about shrinkage allowance. Yes or no? And the correct answer for this question is cooling of liquid metal to solid metal. Yes or no? Yes or no? Is it clear? Okay, so let's see another question. Tell me which one is the right answer, and what is the reason behind this right answer. A frame is made with four joints and five members. This frame is a four member and five joints. You can see here. You can see here. Suppose you have a frame like this. This is a frame like this, and here we have five members. This is member 1, 2, 3, 4, and 5. And similarly, if I talk about joints, then A, B, C, and D. So we have this relation: m is equal to 2j minus 3. M is equal to 2j minus 3, and where m is the number of members, and here we have 5 members. And what about j, number of joints? Here we have 4 joints. Now if you put this value on this expression, then here we get 5 is equal to 2 into 4 minus 3. So can I say this is 5 is equal to 8 minus 3? So can I say 5 is equal to 5? So simply here we get this condition, and this is the condition for perfect truss. So if I say the types of truss, you can see here. So let's see little bit about truss. So here we have two types, that is perfect, and another one is that is imperfect. Yes or no? Perfect truss and imperfect. And if I talk about perfect truss, so for this here we have one condition, that is m is equal to 2j minus 3. This is called perfect truss. And if I talk about imperfect truss, so obviously m is not equal to 2j minus 3. So here we have two conditions: either m is greater than 2j minus 3 or m is less than 2j minus 3. So if we have this here, I am writing if m is greater than 2j minus 3, means the number of members are more than the required number of members. Yes or no? So this is the condition for a redundant truss. This is the condition for redundant truss. Yes or no? This is the condition for redundant. And this redundant truss is nothing but this is stable truss. It is always stable in nature, but it is called as superstructure. This is called as superstructure. Is it clear? And how we can say, if I add one more member on this, if I add one more member on this, then we can say this is called as redundant truss. And if we add this extra member, then obviously this is a zero force member. In this member we have zero force. Why we have zero force? Because all the forces are accommodated by the remaining five members only. In this member there is no force, but we provide this kind of things. Why? Because we ensure for any circumstances. Yes or no? correct. So this is called superstructure, and this is stable truss, although this is redundant. And why it is called redundant? Because we can also say this is internally indeterminate structure which cannot be solved by using static equilibrium condition. Yes or no? For solving this kind of structure you need more equations, and which can be obtained by deflection. Yes or no? Correct. That's why it is called as imperfect truss, but it doesn't have this meaning कि imperfect हो गया तो ये unstable हो जाएगा. This is stable truss, this is superstructure. Is it clear? Okay. And next one, that is if m is less than 2j minus 3, then this is called as deficient truss. Then this is called as deficient truss or deficient frame. And deficient frame means the number of members required is less. Yes or no? Similarly, if in this figure if I remove this, so only we have four members, force joint, then when you apply one force on it, then it will move like this. Yes or no? Correct. So that's why it is called as, this is unstable. This deficient truss is a unstable truss. Is it clear? This is unstable truss. This is unstable truss. Is that clear? And it has less number of members. In actual requirement से कम members हैं यहाँ पे. Is it clear? So the which one is the correct answer? Correct answer is option 2, that is perfect truss. Why answer 2 is the right answer? Because in the perfect truss the number of members, it must be satisfy m is equal to 2j minus 3 condition. And what about question number 27? Tell me, which one is the right answer? Which one is the right answer? Anyone? Tell me. Okay, so you can see a mirror image for 2D reflection is generated relative to an axis of reflection by rotating the object. So this is very simple question. You must remember this. Answer 180 degree. Is it clear? 180 degree is the right answer. Okay, so what about this question? A number of forces are acting simultaneously on a particle. You can say, let's say, suppose if you have a particle, and in this particle we have one force here, another force here, one force is here, one force is here, like this. The resultant of these forces, let's say the resultant of these forces are acting somewhere here. Resultant force may act like this. This is resultant force, this is F1, F2, F3, and this is F4. So this is the resultant. So the resultant of these forces will have the same effect as produced by the forces. Is that clear? So this principle is known as, so the correct answer is physical independence of the force. Is it clear? Is it clear? So देखो, जो ये इंडिविजुअल फोर्स है जो इफेक्ट प्रोड्यूस करेंगे वही सेम इफेक्ट प्रोड्यूस करने वाला है आपका रिजल्टेंट फोर्स. दिस इज कॉल्ड एज प्रिंसिपल ऑफ इंडिपेंडेंस ऑफ फोर्स. And if you confuse with this, so simply if I say the transmissibility of force is nothing but, suppose if you have a body and this is the line of action, so if you have one force which is acting somewhere here, is that clear? So line principle of transmissibility of force tells us if you shift this force from here to here, then it will produce the same effect. Then it will produce the same effect as the effect produced by this force. Yes or no? This force will produce same effect, but this force must be acting along the same line of action, and the point where this force act must be the integrated part of the body. Is it clear? That this is called as transmissibility of force. It never tells about the resultant force. That's why this is the wrong answer. What is the resolution of force? If I talk about resolution of force, so if you have number of forces acting on the body, so for determining the resultant force, first we need to resolve these forces along this axis, along this axis, along this axis, or along this axis. And after resolution, we need to calculate summation of net horizontal force, summation of net vertical force. And once you get this, then simply you can write resultant force is nothing but summation of horizontal force square plus summation of vertical force square. Yes or no? Correct. So it also never tells us the about the resultant, uh, the effect of force and their resultant effect. Correct. And now if I talk about equilibrium force, so what about equilibrium force? Then obviously in this figure you see this is the resultant force. If I calculate the resultant of these forces, four forces, then we get this is the resultant force. So this law it tells us if you apply one force which is exactly opposite to the resultant force, exactly opposite to the resultant force, This is called equivalent force. This is called as equivalent force, which is exactly opposite to the resultant force. And when we have this kind of system, then we can say this system is in equilibrium. So this is tells us about equilibrium condition. Again, not about the this things which is mentioned in the question. Yes or no? That's why the correct answer is option 3. Okay, so what about this question? Can you try to solve this question? This is question number 29. Okay, so you can see a rectangular steel bar of size 100 by 25 by 20 means 100 is length, 25 is its width, and 20 is its length. Sorry, thickness 100 by 25 by 20. All dimensions are in millimeter and has an strain along x, y, and z direction. So strains are given. Let's say Ex is nothing but this is 0.065 and Ey is nothing but this is 0.0025 and Ez is nothing but this is 0.002. Yes or no? These are the strains. Correct. So the change in volume due to these strains are so can I say the volumetric strain is nothing but this is a delta v by v naught. And what about this? This is nothing but this is algebraic sum of strain induced along x, y, and z direction. तीनों डायरेक्शन की स्ट्रेन को सम कर दो. This is called as volumetric strain, and this is nothing but this is delta v by v. So simply here we need to calculate delta v. And what about v naught? V naught is nothing but this is 100 into 25 into 20 into what about this? So simply if you add this, then if I write here, so can I say this is equal to volumetric strain? So this is 5, 5, 10 plus 2, that is 12, 2 and 6, 6 plus 2, that is 8. Okay, so here we have till okay, so like this. So okay, so like this. So this is 002. So this is wrong. Actually here 5, 5 plus 10, this is 0, 1. So 6 plus 2 plus 2, this is 10 plus 1, 1. And this is 1 and 0, 0.0. So this is 0.110. So this is 0.0110. Correct? So what about this? When you calculate this, then you will get this answer 550 millimeter cube. Is it clear? So so are you getting how I am solving this question? So the key point is this: the volumetric strain is nothing but this is algebraic sum of all the strain induced along x, y, and z direction. Is it clear? X, y, and z direction. This is called volumetric strain. Yes or no? And what about this? The CNC machine, operates can set the 0 point at any position on the machine table. This feature is called as floating zero. This is called as floating zero. Is that clear? So you just remember this. The lattice structure of the ferrite iron at the room temperature is, obviously this is called as alpha ferrite. And in alpha ferrite we have BCC. In austenite we have, this is austenite, it has FCC. And at a very high temperature we have delta ferrite, and in this we also have BCC. So you must remember these three crystal structure. Yes or no? Correct. In alpha ferrite we have BCC, austenite we have FCC, delta ferrite we have BCC. And since this material may appear or different crystal structure at different temperatures, that's why this is called allotropic material. Okay, so the correct answer is body centered cubic. Yes or no? And what about this? So you can see this question: the vernier caliper has main scale with 10 division for 1 centimeter and vernier scale has 10 division for 9 mm, the least count of the caliper is. So how you calculate least count? So least count is nothing but this is main scale reading minus vernier scale reading over the number of division provided on the vernier scale. Number of division provided on the vernier scale. So simply we can say this is 10 minus 9 over 10, and this is nothing but this is 1 by 10, or we can say this is 0.1 millimeter. So the correct answer is option 3. Is it clear? So what about this? In a simple lever of the third order, the position of the effort, load, and fulcrum is. So generally, most of the students may miss this topic. Yes or no? The application. This is the application of principle of movement. Is that clear? So in the mechanics, when you study Vagnon's theorem, so you must also read this part. Correct. So now let's see. Here I am concluding this. So if I talk about lever, so basically we have two types of lever, that is, and what is lever? So lever is nothing but here in which we have a rod, and in this rod here we have a fulcrum, and at the one end here we apply effort. This is effort which is represented by P, and here we can lift some weight. Yes or no? This is called as weight lifted. This is called as weight lifted. Yes or no? So if I talk about the mechanical advantage, so mechanical advantage is nothing but this is weight lifted. This is weight lifted over effort applied. Correct? Effort applied. This is called as mechanical advantage. Yes or no? So you must remember this. And this mechanical advantage always greater than 1. Correct? So obviously हम lever किस लिए use करते हैं? By applying less effort we can lift more weight. Yes or no? This is the basic principle of lever. So actually if I talk about the types, lever types, then here we have two types. First one is simple lever, and second one is compound lever. Actually when you need very huge amount of mechanical advantage, means 120 times, 130 times, 1000 times even, correct, means by applying 10 Newton force you want to lift 10,000 Newton weight. Yes or no? Correct. So simply we can say in this case we use compound lever. Correct. But sometimes when you need 10 times, 20 times mechanical advantage, then we use simple lever. So in simple lever of here we have three you can see three order lever. Yes or no? Correct. So first order, second order, and third order. So if I talk about first, second, and third order, so simply you can say here it is looking like this. Suppose you have a lever like this, in which we have fulcrum at the center. Here we have load applied, and here we have this is load lifted. So if you have effort and load lifted exactly opposite to each other from the fulcrum, then this is called first order lever. This is called as first order lever. Yes or no? This is called as first order lever. Similarly, if you have a lever mechanism like this, this is your fulcrum. This is your fulcrum. O is represented by fulcrum. Is that clear? Suppose this is fulcrum and this is the weight जिसे आपको lift करना है, and if you apply, this is the effort. If effort is acting at the furthest point of this lever, if effort is acting furthest point of the lever, correct, and the weight lifted is lie on in between fulcrum and the effort, then this is called as second order. This is called as second order lever. Yes or no? And if I talk about third order lever, so you can see here in this case the load is putting here, this is load lifted here, and this is effort applied here. Yes or no? Effort applied here. Yes or no? So with the help of this P means effort applied, we lift this weight. So if we have this kind of thing, the load lifted is furthest point, is situated at the furthest point of the furthest point at the lever, yes or no? And the effort applied is lie on in between the fulcrum and the effort applied, and effort and weight lifted both are situated at the same side of the fulcrum. Then this is called as third order. This is called as third order. So in this question actually we have third order fulcrum, yes or no? So in a simple lever, the third order position of effort, third order, the position, effort and load and the fulcrum is. तो यहाँ पे देखो क्या, in third order we have load lifted and effort both are at the same position, sorry, in the same side of the fulcrum. So the effort is in between the fulcrum, you can see the effort is in between the fulcrum and the load lifted. Obviously this is the effort which is lie on in between the fulcrum and the load lifted, and the load and the same and the fulcrum and the load on the same side of the fulcrum. Load and effort applied both are in same side of the fulcrum, yes or no? So the correct answer is this one. Now let's see one by one these options also. The load is in between the fulcrum and the effort, in between the fulcrum and the effort. So this is called as second order. This is called as second order, yes or no? The fulcrum is in between the effort. This is called as first order. This is called as first order lever, yes or no? The effort and the load are equidistant to the fulcrum. This is neither first nor second order, yes or no? Is it clear? So the correct answer is option 4. So I hope you will understand about little bit about the lever. Yes or no? Okay, so let's see another question. The Taylor's two life equation Vt to the power n is equal to constant. The value of n for ceramic. So obviously, if you write, if I write material here, if I write material, so here we have HSS, high speed steel, then carbide tools, carbides, and then ceramics. And if I write their ranges, so obviously the value of HSS is less than 0.2, and for carbide, if I say this is lie on in between 0.3 to 0.5, sorry, 0.3 to 0.3 to 0.5, or you can say 0.45, not point. Correct. And if I talk about ceramics, so its value is ranging from 0.5 to 0.8. Yes or no? So let's see which one is the right answer. For the Taylor tool life equation, we to determine the value of ceramic tools. Obviously, ceramic tools की value क्या होगी? 0.45 से ज़्यादा होगी. So the best suitable answer is this, 0.4 to 0.6. Actually, we have this range 0.5 to 0.8, and in some books we see 0.45 to 0.8. Yes or no? So don't worry about this. Correct? Okay, so let's see another question. The water is flowing through a pipe with a mean velocity of 2 meter per second. The approximate kinetic head of the water is. So what about kinetic head? So can I say kinetic head, kinetic energy head is nothing but this is V square by 2G. V square by 2G. Yes or no? With the help of this, okay, let's see Bernoulli equation. So can I say this is Z plus V square by 2G plus P by rho G. This is equal to constant, where Z is a potential head, potential energy head. This is kinetic energy head, and this is pressure head. Yes or no? So here we need to calculate velocity head. So this is V square by 2G. So simply V is given, that is 2 meter per second. So 2 square by 2 into, let's say if I use G, instead of G we use 10. So can I say this is 4 by 20, and this is nothing but this is 0.2. So the correct answer is option 3. Yes or no? Okay, so what about open circuit voltage? So its range is approximately, this is in in AC welding we use 80 volt. Yes or no? So obviously it is lie on in this option only. Correct? Open circuit voltage is lie on in this range 50 to 90 volt. Mostly we have 80 volt. And even जो आपने problem solve किए होंगे previously, तो उसमें यही value given होगी. Is it clear? Okay, so what about the next question? A casting of volume V and the surface area is cooled in an open air naturally. The time required for solidification of the casting. So Sevenov's equation, from Sevenov's equation we can say the solidification time is nothing but it can be written as K into V by surface area whole square. Yes or no? Can I write this expression yes or no? From this, which one is the right answer? The casting, we need to find, yes, the time required for the solidification of the casting is directly proportional to V by A square. So the correct answer this. Is it clear? This is very that directly formula based question. Now you can see in a diesel cycle the heat supplied during the compression for the from the external source is. So obviously if I draw air standard cycle for diesel cycle, so can I draw it is looking like this? Yes or no? This is 1, 2, 3, 4. This is compression, isentropic compression. This is constant pressure heat addition, and this is also this is isentropic. You can say this is isentropic, and this is isentropic expansion. Sorry, isentropic expansion, and this is constant volume heat rejection, and this is constant pressure heat addition. Yes or no? Correct. So the correct answer is constant pressure heat addition. Yes or no? So I hope you will understand why it is right answer. Yes or no? Very simple question. And what about this? सो आई थिंक ये क्वेश्चन देख के आपको थोड़ा सा कॉन्फिडेंस फील हो रहा होगा कि दीज क्वेश्चंस आर ईदर बेस्ड ऑन डायरेक्ट फार्मूला और वेरी फ्यू क्वेश्चंस आर फ्रॉम मेमोरी बेस्ड यस आर नो एंड दे आर वेरी सिंपल क्वेश्चन एक्चुअली and in a very less time you can easily solve it yes or no but you know each and every concept thoroughly yes or no so for any competitive exam you need to prepare once in such a way that you know each and every concept and you also practice more and more questions yes or no करेक्ट तो फिर कोई भी एग्जाम आपके लिए बड़ी चीज नहीं होगी ओके लेट्स सी अनदर क्वेश्चन अ balloon is floating in the air and is in equilibrium you can see whenever we see this kind of question a balloon is floating so this question belongs to a fully submerged body fully submerged body so don't be confused with this whenever you have volume actually if I talk about volume then volume is obviously it is surrounded by air throughout the periphery yes or no and in water if I say if this is datum so if any body is situated somewhere here inside the water then we can say this is fully submerged body yes or no but if a body which is floating then it is looking like this is called as floating body and in floating body we have 3 points that is this is M this is G and this is C where M is the meter center G is the center of gravity and C is the center of pressure so for the stability condition in floating body is like this meter center must be lie on above the center of gravity must be lie on above the center of pressure but when we talk about fully submerged body then here we have only 2 points you can say for this if I draw like this is it clear so here we have only 2 points that is center of gravity and this is center of pressure so for stability condition of this fully submerged body or balloon is floating on the air what we need to do you can see here the center of gravity must be lie on above the center of gravity must be lie on below the center of buoyancy this is wrong this is center of buoyancy and this is center of gravity correct so you don't be confused with this balloon is floating in the air iska matlab kya hai कि this is a case of fully submerged body this fully submerged body means it is looking like this is a floating body yes or no this is a floating body yes or no this is a floating body when some portion of the body is submerged in the water and some portion is not submerged then this is called as floating body तो यहाँ पे इस floating term से confuse नहीं होना है correct? And for fully submerged body we only have two points, two centers जिससे हम इसके इक्विलिब्रियम कंडीशन को डिफाइन कर सकते हैं. इज इट क्लियर? बट फ्लोटिंग बॉडी के लिए थ्री इंपॉर्टेंट पॉइंट्स होते हैं, इनसे हम इसको डिसाइड करेंगे वेदर योर बॉडी इज इन इक्विलिब्रियम और नॉट. इज इट क्लियर? ओके, सो व्हाट अबाउट दिस क्वेश्चन? A single plate disc clutch is used to transmit torque with the axial load W. The mean radius of the surface of the friction material is R, and the coefficient of friction for the clutch material is mu. The frictional torque transmitted for a case of uniform axial wear is that. This is very simple. It can be represented like this. You must remember this formula. Is it clear? The torque transmitted must be equal to mu WR. Yes or no? Mu WR. Yes or no? Is it clear? This is the coefficient of friction, this is the axial load, and this is the mean radius. And obviously, if you use uniform wear theory or uniform pressure theory, if I talk about uniform pressure theory, then on the basis this, the mean radius can be represented like this: 2 by 3 times R naught cube minus Ri cube over R naught square minus Ri square. And similarly, on the basis of uniform wear theory, we have this relation, that is R naught plus Ri by 2 only. Is that clear? Okay, so let's see another question. When a tensile specimen loaded beyond the yield point and then load is released, the elastic strain recovery is indicated on the stress strain curve as a line. So you can see this is very nice question, and many times nowadays every classes of in material science and strength of metal I always discuss this concept. So once again you can see. So if I draw stress versus strain diagram, so you can see here it is looking like this, correct? But obviously we load up to this point. This is the point up to which the material is loaded, and obviously this point is situated at some plastic region. Yes or no? This is your elastic limit. This is your elastic limit. Yes or no? This is your elastic limit. And beyond the elastic limit, if we can load the material up to this point and unload it. So before unloading, obviously we have this strain. Yes or no? This is the total strain. But when you unload it, then it follows this path. Yes or no? It follows this path. So this strain is nothing but, this is called as permanent strain, that is plastic strain, and this is the strain which is recovered. So can I say this is recovered? This is recovered strain. So in this question you can see here, when a tensile specimen is loaded beyond the yield point, this is yield point. Beyond the yield point, if we can apply load, then the load is released, the elastic strain. If I say this is the yield point, if I say this is yield point, SYT, correct? So beyond the yield point, if we load and then unload it, then the elastic strain recovery is indicated on the stress strain curve. So this is the elastic recovery along the original elastic curve. Incorrect answer. Along the y-axis of the, yes, this is wrong. Along the x-axis, this is right. Vertical line from the point of release to the return point means, simply if I draw vertical line from here, vertical line from here, and from here, so this gap is called as elastic recovery. This region is called as elastic recovery. This amount is, the amount of this strain is recovered completely when you unload it. Yes or no? So the correct answer is option 3. Okay, so what about this question? A wheel accelerates. A wheel accelerates uniformly from a velocity of 10 radian per second to 60 radian per second in 20 seconds. So what is angular acceleration? So can I say this is nothing but, simply can I say this is, let's say omega 2 is nothing but, this is omega 1 plus alpha times of t. So alpha is nothing but, this is omega 2 minus omega 1 by t, correct? So Newton's law for uniform acceleration, for rotation actually. So here we have 60 minus 10 over 20 seconds. So 50 by 20. So can I say this is 2.5 radian per second? Sorry, per second square, not per second. Radian per second square. So the correct answer is option 1. Yes or no? Okay, so the each factor in the chemical machining process. So what is etching? Actually, etching means when you put the sample, when you put metallic sample in the acid, then some chemical reaction takes place, and due to that chemical reaction, some amount of material get dissolved into the chemical. Yes or no? So on that portion we get some crater. On that portion we get some crater. So the etching factor is nothing but it is the ratio of undercut over depth of cut. Yes or no? Obviously, you can say, let's say, suppose you have material like this. Yes or no? And now, if you perform chemical etching process, chemical machining process, then some amount of material get removed from this zone. Yes or no? Some amount of material get removed from this zone. इज इट क्लियर? बिकॉज ऑफ केमिकल इजिंग, क्यों यहाँ पे क्या होगा, हाइड्रेट्स के फॉर्म में ये केमिकल के थ्रू ये क्या होंगे, आयरन, अगर लेट से ये आयरन है तो आयरन हाइड्रेट्स के फॉर्म में ये रिमूव हो जाएगा, आयरन डिस्प्लेसमेंट. सो द करेक्ट आंसर फॉर दिस क्वेश्चन इज अंडर कट टू द डेप्थ ऑफ कट. किस डेप्थ तक ये हमें कट कर दे, दिस इज अंडर कट एंड दिस इज डेप्थ ऑफ कट. सो यू हैव दिस डिस्टेंस and you have this distance. So this ratio is called as etching factor. Is it clear? This is called as etching factor. Okay, so now let's see another question. A shaft is subjected to a bending moment of 30 Newton millimeter and twisting moment 40 Newton millimeter. The equivalent twisting moment on the shaft is. So as you know that the equivalent twisting moment is nothing but this is square root of m square plus t square. This is very simple formula. Yes or no? So now if you put this value, so can I say bending moment is 30? So 30 square plus 40 square. So simply here we can 50. Yes or no? So the correct answer is 50. If you have any doubt, then you can ask me. Correct? Okay. So the approximate constant of content of carbon in the eutectoid steel. So do you know what is this eutectoid steel? So you can see if I draw iron carbon diagram, then it is looking like this. We have this iron carbon diagram. Is it clear? This is very simple. And if I talk about temperature, this is 1539 degree centigrade, और इसके corresponding temperature होगा 1493. Corresponding to this, here we have 1410. इसके corresponding we have 910, and corresponding to this, here we have 725 degree centigrade, and here we have 1150 degree centigrade. Yes or no? Correct. So obviously this is called as eutectic point. Sorry, eutectoid point. Yes, you need eutectoid point. So corresponding to this, here we have 0.8% carbon. Here we have 4.3% carbon. And if I talk about this point, so obviously at this point here we have 0.18% carbon. So you must remember these 3 points. This is point 1 eutectic, eutectoid, and this is peritectic. Is that clear? This is eutectic, eutectoid, peritectoid. Sorry, peritectic, not peritectoid. This is peritectic. And generally ये students को याद नहीं होता. At 0.18% carbon and 1493 degree centigrade, this reaction takes place in which one liquid, in which one liquid, you can see here you have delta. This is first transformation of iron, and here you have liquid. So delta plus liquid will be converted into another solid, and that solid is nothing but this is austenite. At what temperature? 1493 degree centigrade, and what composition? 0.18% carbon. ये कहलाता है, this is called peritectic reaction. This is called peritectic reaction. Yes or no? Is it clear? Okay, so let's see another part. The smallest circle that can be drawn from the center of the cam and tangent to the pitch curve of a cam with a roller follower. You must remember this is the correct answer is prime circle. Is it clear? Prime circle. And I think everyone know. Next, you can see the coefficient of contraction CC and orifice can be determined by using the coefficient of discharge and coefficient of velocity. Is that clear? So simply we know that CD is nothing but this is CC into CV. So if I write CC, so can I write this is nothing but this is CD by CV. So the correct answer for this question is option 1. that is CD by CB. Yes or no? And what about this question? What about this question? In the metal forming process, in the metal forming process, the value of stress required for continuous material flow. Oh, this is very simple. Flow stress, yes or no? In the metal forming process, we need flow stress. What do you mean by flow stress? Flow stress nothing but this is the minimum stress required to get continuous plastic deformation of the material. This is called as flow stress. Is it clear? And flow stress is represented by a power law. This is nothing but this is K epsilon to the power n, where n is exponential index. This is also called as strain hardening index, and epsilon is a true strain. This is true strain. True strain. This is strain hardening index. Strain hardening index. Yes or no? And K is nothing but this is strain strengthening coefficient. Strengthening coefficient, and this is flow stress. And this law is called as power law. This is called as power law. Yes or no? So this is all about this concept. Is it clear? Okay, so let's see another question. A compressive load of 2.4 kilonewton act on a circular bar of 200 square cross section area. So let's say you have a circular bar like this and it is subjected to 2.4 kilonewton compressive load like this, and its area of cross section is given, that is 200 square millimeter square area, and height means length is given 20 mm. If it experiences a compression of 0.1 means delta L is given here, that is 0.15. Then the Young's modulus, we need to find out Young's modulus. Do you know delta L is nothing but this is PL upon AE. So from this can I say E is nothing but PL upon A times of delta L. So P is nothing but this is 2.4 kilonewtons. So can I say this is 2 into, simply here I am writing, you can see here. So 2.4 into 10 to the power 3. And what about length? Length is given, that is 20 mm over area 200 square and square millimeter. And what about delta L? This is 0.15. Now when you solve this, then you will get 1600 megapascal. Is it clear? After solving this expression, you will get this result. Yes or no? So this is very simple question. Okay, so now you can see the term H minus Ts. H minus Ts in the deriving the maximum work done for the steady flow system is. So do you know this is G is equal to H minus Ts, and similarly F is equal to U minus Ts. This is called as Gibbs function and this is called as Helmholtz function. Yes or no? So which one is the correct answer? Gibbs function. Yes or no? This is Gibbs function. H minus Ts is a Gibbs function. Is it clear? And what about this? The control chart for the attributes are concerned with checking if the variable is out of control, the actual measurement of the parameters comparing with the standard, qualitative checking for the of the defects, direct measurement of the variable for the control. So actually we have two types of control charts. One is control chart for attributes, another one is control chart for variables. Yes or no? So the control charts for the attributes are concerned with, so actually it is used for measuring, it is used for checking defects only. Yes or no? Is it clear? This is used for checking defects. And if I talk about the control charts for variable, then mainly it is used for checking the number of defects and the defective items. Yes or no? So the correct answer for this question is option 3. Now you can see in underdamped vibrating system, if x1 and x2 are the successive value of the amplitude on the same side of the mean position, then the logarithmic decrement is equal to. So what do you mean by logarithmic decrement? So it is simply nothing but this is ln, logarithmic decrement is nothing but this is ln x naught by x1. Correct? So you can see option 1 is the right answer. Instead of x1 x0 we have x1, and instead of x2 here we have x2. Yes or no? So this is the right answer. Is it clear? This is the right answer. Okay, so let's see another. Braking jets are used. Yes, braking jet. Why it is used for braking jet? Braking jet is mainly used to reduce the speed of the reduce the speed of the turbine. Correct. So to bring the turbine in the rest condition, we use braking jet system. Yes or no? Braking jet system. So the correct answer is option one. Two forces. Now you can see two forces equal magnitude. You can see. Suppose you have two forces with equal magnitude which is acting like this, then what about its resultant? Correct. So can I say resultant is nothing but from parallelogram law of forces, this is F1 square plus F2 square plus 2 times of F1 F2 cos theta. And many times I already told with my students, and my students already know the correct answer. Here F1 F2 is same, so can I say this is 2 times of F square plus this is 2 times of F square cos theta. So simply can I write this is nothing but this is F square 2 times of F square. If I write 2 times of F square in bracket 1 plus cos square cos theta, 1 plus cos theta. So simply can I say 1 plus cos theta is nothing but this is 2 times of cos square theta by 2. 2 times of cos square theta by 2. Here I am writing 1 plus cos theta is nothing but it can be written as it can be written as 2 times of cos square theta by 2. So simply resultant can be written as square root of 2 times of f square. Instead of you can see 1 plus cos theta, can I write this is 2 times of cos square theta by 2. And if you solve this, then you will get 4 times of, yes, simply you can say 2 times of f cos theta by 2 whole square under root. Yes or no? And now if you solve this, then you will get 2 times of cos, sorry, f resultant is nothing but this is 2 times of f cos theta by 2. So this is the correct answer. So 2f cos theta by 2. Yes, option 2 is the right choice. Is it clear? Correct. So how we you get this result by using simple geometry? Yes or no? Simple trigonometric relation. And कौन सा relation है? So you know cos 2 theta can be written as cos 2 theta can be written as cos square theta minus sin square theta. Yes or no? So cos theta can be written as cos square theta by 2 minus sin square theta by 2, and also we know that sin square theta by 2 is nothing but this is 1 minus cos square theta by 2. Now if you put this value on this expression, then you will get this result. Yes or no? So I hope you will understand how to determine 1 plus cos theta value, and once you get this, you just put on this expression and you will get the final answer. Yes or no? Okay. So what about next question? A body which can be retained its shape and size even it is subjected to external force is called as, this is called as rigid body. Obviously a body is said to be rigid when we apply some force, then it retain their original shape and size, and this is called as rigid body. Yes or no? And if it will deform or it will change its original shape and size, then this is called as flexible or deformable body. Yes or no? This is a very simple question. And now you can see another question. I already discussed with you the true stress strain relationship for plastic deformation at which necking begins may be appointed the value, and for the steel is sigma t. You can see here we have power law. Sigma t is nothing but this is k epsilon t to the power n. This is called power law. And for steel, the value of n is approximately 0.21, and you must remember this value. Yes or no? You must remember this value. Is it clear? So this is memory based type question. Okay, so what about this? A stone is directly dropped from the building top of the building which is 8 meter height. So you can say, let's say suppose we have a building like this. This is a building, और यहाँ से अगर मैं एक स्टोन को थ्रो करूं, yes or no? So just before the strike, what is the velocity of this stone? And its height is 8 meters. So can I say the velocity of the stone at this height is nothing? This is root 2gh. So what about this? 2 into, let's say if I take G, and what about this G, sorry, H, here we have 8. So simply here we can get 16G, or you can say 4 root G. So the correct answer is option 2. Yes or no? Okay, so what about this question? What about this question? The perpetual motion machine of first kind is impossible. This statement is the corollary of. So you always remember two concepts. That is perpetual motion machine टाइप 1. सो ये कहाँ पे आएगा? फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स. फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स, एंड इट टेल्स अस विदाउट प्रोवाइडिंग, वंस एक बार आपने इसको एनर्जी प्रोवाइड की एंड देन वी रिमूव इट, एक बार हमने एनर्जी प्रोवाइड किया इस मशीन को, देन इट विल प्रोड्यूस कॉन्टिन्यूस वर्क. Yes or no? This is called as perpetual machine. It is impossible to construct this kind of machine which take energy once and perform work continuously. Yes or no? This is called as perpetual motion machine, first kind, and it is based on first law of thermodynamics. And second one, that is perpetual motion machine type 2. So it tells us, and we study this thing in second law of thermodynamics, and it tells us by consuming energy from single reservoir, it will produce continuous work. There is no heat rejection. There is no heat rejection. So this perpetual motion machine tells us it is impossible to construct a device which work on single reservoir. It takes energy from single reservoir and produces continuous work. Is it clear? This is called as perpetual motion machine type 1. So the correct answer is first law. Is it clear? Oh. Okay, so the correct answer is first law of thermodynamics. Okay, so what about next question? The ratio of relative lateral strain normal to the applied load to the relative axial strain. This is very simple. This is called Poisson's ratio. Poisson's ratio is nothing but lateral strain. You can see, suppose you have an object, it is subjected to stress somewhere here, and let's say this is x direction and this is y direction. So strain induced along x direction, this is called as longitudinal strain. Yes or no? And the strain along y direction, this is called as lateral strain. So you always remember, lateral strain always induced across the applied load. Along the applied load always we get longitudinal strain, across the applied load we always get lateral strain. And the Poisson ratio is nothing but this is the ratio of lateral strain to the longitudinal strain. Is it clear? So the correct answer is Poisson's ratio. The correct answer is Poisson's ratio. Okay, so what about this? Water is flowing through a square pipe 100 millimeter side with an average velocity of 10 meter per second. The rate of flow of water is, so can I say Q dot is nothing but area into velocity? This is very simple formula. And what about, here we need to find the rate of flow of water. Correct. So volume flow rate actually we need. So area is given, square is 100 square. So can we write 100 square? This is area of cross section of a square pipe into velocity, that is 10. So simply it can be written as 10,000 into 10, that is, and if we convert this is in meter, yes, this is written in the meter and this is in millimeter. So simply can I say this is 0.1 whole square, 0.1 whole square into 10. So if you solve this, then you will get 0.1 meter cube per second. Yes or no? 0.1 meter cube per second. And one more thing, you must remember 1 liter is nothing but this is 10 to the power minus 3 meter cube. And somewhere अगर आपको जरूरत पड़े, you need to convert meter cube into liter, then with the help of this relation you will change it. Yes or no? Okay, so and one more thing, this PDF is already available in the website. Yes or no? तो दोस्तों अगर आप चाहते हो इस PDF को, तो you just go to the website, YourPedia website, and download it. Yes or no? In the PSU section, correct? And this model will start at 25th of August this month. So if you are planning to prepare this exam, then definitely you will join this module, because this is very important module and especially designed for this exam. And this module is already running from last 2 years. So this is third consecutive year in which we provide exclusive module for HPCL exam. Is it clear? Okay, so let's see this question. Which of the following is usual approximately composition of the soft solder used in the soldering? So you just see, अगर आपने यहाँ पे यूटेक्टिव फेज डायग्राम पढ़ा है लेड टिन का, then you can see here I am going to draw the phase diagram like this. It is looking like this, correct? So this is what temperature? This is 183 degrees centigrade, and this is, here we have 100% lead, 100% lead Pb, and here we have 100% tin, and here we represent percentage of tin. So at this point here we have 63% tin. So if you have 63% tin, means 37% we have lead. Yes or no? So a composition in which we have 63% tin and 37% lead is called as solder. 37% lead and 63% tin. Yes or no? And this is eutectic phase diagram for lead and tin. And this diagram already I discussed in my materials engineering materials class, correct? So what about this? In a flywheel, the maximum and minimum speed in a cycle are 180 and 120 rpm respectively. Then the coefficient of fluctuation of speed is. So actually we need to calculate CES, coefficient of fluctuation of speed. So it is nothing but it can be written as maximum speed minus minimum speed over average speed. So what about this? This is 180, this is minus 120, and what about average? And average is nothing but this is n maximum plus n minimum over 2, and this is 180 plus 120 over 2. So this is 150. So simply if I put 150, so here we get 60 over 150. So this is a 2 by 5. This is 40%, means 0.4. Yes or no? 0.4 is the right answer. And what about this? Impulse water turbine works under the head of 40 meter. So water head is given already, which is 40 meter. Water is supplied through turbine, that is 2.5 meter cube per second. Then the power available. So what about power? Simply we can say rho GQ into H. With the help of this formula, we can calculate power. Yes or no? Here we have each and everything. This is 1000. Let's say this is 9.81, and this is 2.5. 2.5 into 10 to power, sorry, 2.5 meter cube, and each and everything is written in the meter. So don't worry about this. And 40. If you solve it, then here you will get 981 kilowatt. Yes or no? Obviously you need to divide with 1000 for getting kilo power in kilowatt. Yes or no? So this is formula based question. So as already we see 64 questions. So from the previous question we see very simple question may asked, yes or no. Many questions asked directly from formula, and very few questions asked from a memory based. Yes or no. So if you know thoroughly concept of this entire engineering, mechanical engineering, then definitely you can solve approximately 80 plus questions out of 85 questions. यस आर नो, करेक्ट? तो अगर आपने प्रिपरेशन अभी तक स्टार्ट नहीं की है तो स्टार्ट कर दो, एग्जाम 100% निकलेगा. इज इट क्लियर? एंड नाउअडेज द कंपटीशन इन मैकेनिकल इंजीनियरिंग इज वेरी लेस एज कंपेयर टू पास्ट 5 ईयर. यस आर नो? तो ये बहुत ही गोल्डन अपॉर्चुनिटी है. एंड नाउअडेज प्रेजेंट में मेनी एग्जाम्स आर गोइंग ऑन. यस आर नो? बहुत सारी वैकेंसीज ऑलरेडी हो चुकी है, पीएसयू गेट के थ्रू हो चुकी है, बहुत सारे एग्जाम्स अभी भी कंटिन्यूअसली कंडक्ट हो रहे हैं, न्यू वैकेंसीज आ रही हैं. अगर आपने अभी तक प्रिपरेशन स्टार्ट नहीं की तो प्रिपरेशन स्टार्ट कर दो, कहीं ना कहीं जरूर फिट हो जाओगे. यस आर नो? इज इट क्लियर? और यू कैन सी हियर दिस इज द HPCL क्वेश्चन पेपर इन विच वी हैव वेरी सिंपल क्वेश्चन. यस आर नो? वेरी वेरी सिंपल क्वेश्चन. आपको थोड़ा सा एफर्ट लगाना है, थोड़ी सी एफर्ट लगानी है, एंड यू विल गेट द सक्सेस. यस आर नो? करेक्ट? तो जस्ट little effort, by putting little effort you will get the very huge success. Yes or no? Is it clear? तो थोड़ा सा मेहनत कर लो बालकों, करेक्ट है? नाउ दिस टाइम इज अ वेरी वेरी क्रूशियल टाइम, बहुत ही गोल्डन अपॉर्चुनिटी है, और कंपटीशन सबसे लीस्ट लेवल पे है मैकेनिकल इंजीनियरिंग में। इज इट क्लियर? और अब अगर नहीं किया तो फिर जीवन में कभी मौका नहीं मिलेगा, ध्यान रखना। तो दिस इज द राइट टाइम। इज इट क्लियर? और यहाँ पे YourPedia टीम आपकी हेल्प करने के लिए यहाँ पे हमेशा तैयार है, करेक्ट है। एंड नाउ यू कैन सी, एंड एवरी डे आपको 5 o'clock में कोई ना कोई सेशन मिलेगा, करेक्ट है, HPCL का। तो आप कंटिन्यूसली ज्वाइन करिए, एंड इवन आफ्टर दिस सेशन अगेन वी विल मीट इन द सम नेक्स्ट डे, yes or no, in the upcoming days, not exactly in the next day. Is it clear? With a new paper. Okay, so you can see according to the law of collision, elastic body, the value of coefficient of restitution for the two inelastic body. So you can see the coefficient of restitution is nothing but it is the ratio of velocity of separation, velocity of separation, velocity of separation over velocity of approach, over velocity of approach, the velocity of approach, and it can also be written as v2 minus v1 over u1 minus u2, yes or no? And for inelastic body, for inelastic body we have E is equal to 0, and for elastic, perfect elastic body, for perfect elastic body, perfect elastic body, we have E is equal to 1. And remember, the value of coefficient of restitution is always varying from 0 to 1. Is it clear? So the correct answer is E, sorry, 0 for inelastic body. Okay. Okay, let's see another question. And a refrigerator absorbs the heat of 27 kilojoule per second at a minimum temperature. The work required to run the refrigerator if the coefficient of performance is 3. So you can see here we need to calculate minimum temperature. So can I say the COP is nothing but desired effect over work input required? Is it clear? Correct. So from this COP is given, so you need to calculate the work input. So this is desired effect over COP. And what is desired effect? 27. And what is COP? This is 3. And the answer is 9. And since this unit is kilojoule per second, so we have 9 kilojoule per second. So the correct answer is option first, that is 9 kilojoule per second. And second question, you can see an oil of 2.5 liter weight, 5 Newton at room temperature, the specific weight. So what is specific weight? That is small w, which is nothing but that is capital W by volume. Weight per unit volume is called a specific volume, specific weight. Yes or no? So weight is given already, that is 5 Newton. And what about this oil volume? That is 2.5 liter. So simply can I say this is 10 to the power minus 3. And I already told you 1 liter is equal to 10 to the power minus 3 meter cube. So here we get this term in Newton per meter. So this is 5000 over 2.5 Newton per meter cube, or simply we can say W is equal to 2 into 10 power 3 Newton per meter cube, or 2 kilonewton per meter cube. Yes or no? तो देखो कौन सा आंसर है? Yes, 2 kilonewton per meter cube is the right answer. The key point is this: 1 liter is equal to 10 to the power minus 3, and you must remember this relation. जब भी स्पेसिफिक की बात आएगी, या तो वो पर यूनिट मास होगा या पर यूनिट वॉल्यूम होगा, ये हमेशा ध्यान रखना. Is it clear? बहुत ज्यादा यहाँ पे दिमाग नहीं लगाना. Okay, what about this? What about this? A reversible engine with 25% operates with a higher temperature of 127 degrees centigrade than the sink temperature is. Obviously, we know that any device which works on two thermal reservoir, this is called as source and this is called as sink. And obviously in sink we have lower temperature, in source we have higher temperature. And let's say if this is heat engine, then obviously it will produce some work. Yes or no? So if I write efficiency of the system, then this is nothing but this is 1 minus TL by TH. Yes or no? So efficiency is given, that is 25%. This is 20.25. 1 minus, we need to calculate TL. And what about TH? 127 degree centigrade. यहाँ पे ध्यान रखना, यहाँ पे ध्यान रखना. This is the key point. Whenever you have temperature in degree centigrade, first you convert in Kelvin. Yes or no? First you convert in Kelvin. Is it clear? Then you put the value. So if you convert this 127 degree centigrade, so can I write 127 plus 273? So this is 400 Kelvin. Yes or no? So after solving this, TL is nothing but, can I write directly 100 into 1 minus 0.25? So here we get 400 into 0.75. Yes or no? So this is nothing but, this is 300 Kelvin. But here we need to give this answer in degree centigrade. So what about degree centigrade? So can I write, this is 300 minus 273. So this is 27 degree centigrade. 27 degree centigrade. Option 4 is the right answer. Yes or no? This is the key point. This is the key point. Before solving thermodynamics problems, first you need to convert temperature scale from degree centigrade to Kelvin scale. Yes or no? From degree centigrade to Kelvin scale. Yes or no? Okay, so let's see in this question. The relative relationship between Young's modulus and the modulus of rigidity using the Poisson's ratio is, this is very simple question and most of the exam में तो ये आता ही आता है. And this is 2g into 1 plus mu. You must remember 3k into 1 minus 2 mu. You must remember, and this is equal to 9 kg over 3k plus g. These are the three relations. So you must remember these three relations. So from this, which one is the right answer? Option 1. G is equal to E upon 2 times of 1 plus mu. Yes or no? This is very simple question. Okay, let's see another question. The nominal thickness of the boundary layer is defined when the velocity reaches the velocity of the free stream. Yes, this is very simple question. Very simple question. If you draw velocity profile, then you will get, and if the velocity is close to 99%, or simply you can say 0.99 times of average velocity, maximum velocity, not average, correct, then we can say the nominal thickness of the boundary. Is that clear? So correct answer is this. So a system in which the energy of the matter flow into or out the system is called as open system. Very simple question. A system in which the energy or a matter flows open system. यहाँ से गर्मी heat दो, यहाँ से भाप निकलेगा. Yes or no? Steam can move outside and heat will also move outside. Then this is called as open system. In adiabatic system, neither mass nor heat can transfer, and this is in adiabatic system only heat cannot be transferred, and in isolated system neither mass nor heat can transfer. In transient system in transient system the energy can transfer only. Yes or no? A tank carries an ideal gas at an absolute pressure of 4 bar at 27 degrees centigrade. If the temperature is increased to 60 degrees centigrade, the pressure inside the tank is, obviously if you have a tank, then the volume is remain constant when you add heat. Yes or no? So this is constant volume process, and in constant volume process we know that PV is equal to MRT. This is ideal gas equation. Pressure is directly proportional to temperature. So can I write P2 by P1 is equal to T2 by T1? Yes or no? So from this P2 can be written as P1, that is 4 bar into T2 by T1. What is T2? T2 is 60 degree. 60 degree again you need to convert 273 plus 60 degree, and 27 plus 273 degree. Yes. So after solving this, you will get this answer. So again, don't forget to convert this temperature in Kelvin scale. Yes or no? Sir, does anyone going to give Cochin Shipyard Limited exam on 25th August? तो अगर आपने फॉर्म भरा है तो डेफिनेटली एग्जाम दो, एंड ऑल द बेस्ट फॉर यू गाइस, those students who are planning to give exam in 25th August of Cochin Shipyard exam. Yes or no? Okay, so let's see another question. Next one, you can see this one. The end fixed coefficient is used in the crippling load equation based on the Euler's theory of buckling of column. The value of coefficient of the case or one end is fixed, another end is hinged, means we have a column like this. This is fixed end, yes or no? This is fixed end and this is hinged end. And now if you apply load, then for this if I write critical load of buckling, this is 2 times of pi square ei over L square, and if you compare with this term, then obviously here we have 2 is the right choice, yes or no? 2 is the right choice. 2 times of pi square ei upon L square, yes or no? And this expression is valid for pi square ei upon L square is for which? Tell me, for both end hinged column, yes or no? Both end hinged column. Okay, so what again? This is very simple question. I already told you many times. What is Q? Notch sensitivity factor. This is called as notch sensitivity factor, and this is nothing but this is kf minus 1 over kt minus 1. Actually, this is, it can be written as sigma naught into kf minus sigma naught over sigma naught into kt minus sigma naught. Yes or no? And where sigma naught is a nominal stress, and if you take common from both the parts, then this sigma naught is cancelled out with this, then you will get kf minus 1 upon kt minus 1. So the correct answer is option Q. This is called notch sensitivity factor. Yes or no? The pressure ratio per stage of centrifugal compressor. Obviously, in the centrifugal compressor, the pressure ratio is very less as compared to reciprocating. So the correct answer is सबसे minimum वाला, that is 4:1. Is it clear? 4:1 is the right answer. A double fillet weld is used to join steel plate of 5 millimeter thickness for the length of 20 mm. The allowable tensile strength is 100 megapascal. The tensile strength of the joint. Let's see if you write tensile strength of the joint. So, and this is obviously this is double fillet. So, can I write 2 into 0.707 into sigma t into throat L, sorry, length of the leg into L. So simply you write 2 into 0.707 into 100. And what about T? Let's see. The fillet weld, double fillet weld is used to join the steel plate of 5 mm thickness of the length 20 mm. So thickness is 5 mm. This is called throat height and the length is 20 mm. So if you multiply this, then definitely you will get 14.14 kilonewton. Yes or no? Okay. So let's see another question. An oil having kinetic viscosity of 15 into 10 power minus 4 meter square per second flowing through a pipe of 300 mm diameter. For the velocity of oil 25 meter per second, the Reynolds number. So you know Reynolds number, rho v d by mu, or simply you can say Vd by nu, where nu is a kinetic viscosity and this is dynamic viscosity. Is it clear? So obviously here we have kinetic viscosity, so we use second part. So velocity is given, the how much 25 meter per second. Diameter is given, that is 300 meters. So can I say this is 0.3 meter, and over 15 into 10 to the power minus 4 meter square per second. So by solving this expression you will get this result. Yes or no? Yes or no? Is it clear? So this is very simple formula. इससे आसान पेपर क्या हो सकता है बालकों? The minimum number of teeth on the pinion which will mess with any gear without interface of 14.5 degree full depth involved gear tooth is minimum number of teeth. Listen, we use this relation. Which relation? Number of minimum teeth is nothing but this is 2 times of addendum. If here, since addendum is not given, so we use 1 divided by sine square phi. Is it clear? Sine square phi. Obviously, this expression actually valid for us rack and pinion gear where the radius of curvature is infinite. Yes or no? But this is many times in the question very few informations are given, so we use this relation only. Yes or no? So now if you solve this, then you will get 2 times of sine 14.5 degree whole square. And now if you solve this, then you will get 31.99. Yes or no? And it will be taken as 32. इसको solve करने पे आपको मिलेगा 31.99 और equivalent to हम इसको कह सकते हैं 32. So 32 minimum number of teeth required for 14.5 degree involute tooth. The critical radius of the insulation for the asbestos whose K is given, that is K is equal to 0.125 watt per meter Kelvin. Surrounded a pipe exposed to room air with H is equal to 2.5. So this is very simple question. Critical radius is nothing but it can be written as uh, H by K or K by H. Tell me. H by K or K by H? Tell me any one. H by K or K by H? Tell me anyone. This is and we have two relation. Actually, we have this relation 2K by H and 1K by H. So this is applicable for cylinder and this is applicable for sphere. Is it clear? So obviously here we have the critical radius insulation of the asbestos with this surrounding pipe. Pipe is given. So cylinder we use. So we can use this relation. RC is equal to K by H. Yes or no? And here K is given, that is 0.125 watt per meter Kelvin, and H is given, that is 2.5 watt per meter square Kelvin. So when you solve this, then you will get 50. Is it clear? So you see, here we have two relations, 2K by H and K by H. 2KH is used for sphere and K by H is used for cylindrical body. Yes or no? If we perform insulation on the cylindrical object, then we use this relation, and if you use spherical body, then we use this relation for determining critical radius of insulation. Is that clear? So you can say another question. A unit cell of face-centered cubic crystal structure has face-centered cubic structure FCC. FCC, unit cell of face-centered cubic structure has number of atoms. So obviously here we have 4 atoms. So you can see in simple cubic we have 2, in BCC you have 2, in simple cubic we have 1, BCC we have 2, FCC we have 4, and SCP we have 6. So the correct answer is 4. Yes or no? The analogy of conductivity in heat transfer to fluid is, so obviously Prandtl relations, from Prandtl relation can I say this is a K by rho Cp, yes or no? K by rho Cp by K or K by rho Cp? Tell me Prandtl number. How you represent Prandtl number? Anyone? So Prandtl number is nothing. Yes, mu Cp by K. Yes, this is actually I am writing wrong. Mu Cp by K. Prandtl number is nothing but this is mu Cp by K. Correct? Means actually here we have we get this relation from thermal ratio of thermal momentum diffusivity to thermal diffusivity. So actually this number is used to make a relationship between heat transfer and fluid. Yes or no? So the viscosity is the right answer. Mu, you can say mu is the viscosity. Yes or no? Okay, so the logarithmic mean temperature. This question is always asked from the exam. Correct? What is LMTD? So LMTD is nothing but logarithmic mean temperature difference is nothing but this is theta 1 minus theta 2 over ln theta 1 by theta 2. Yes or no? Theta 1 over theta 2. Is it clear? So you also remember this formula. This is very simple question, a very useful formula. Many times asked in the question. Yes or no? And the oxyacetylene gas used in the gas welding produces a flame temperature of, and you can see oxyacetylene. This is oxidizing flame, and obviously this is hottest flame of the gas welding process. So its temperature is maximum, that is 3200 degrees centigrade. Next question you can see, a gear tooth profile generates using a curve traced by a point on a circumference of a circle that rolls without slipping on a fixed straight line. So let's say suppose you have a straight line and this is a circle, and if you take a point, yes or no, and now if we revolve this circle like this, agar मैं इस circle को rotate करूँ without any slipping, then obviously this point moves like this. Yes or no? Then we can get the cycloidal profile. Yes or no? And similarly, if I talk about involute profile, so if you have a circle, in this, if I trace the tangent, if I trace the tangent continuously, अगर मैं एक लाइन लूं, मतलब suppose if I wrap the string on over the periphery of the wheel, and if we unwrapped it, yes or no, then we get a profile which is known as involute profile, yes or no? Is it clear? So simply we can say, if you revolve the tangent, correct, then you will get the involute profile. So here we have the correct answer is cycloidal profile, yes or no, when you revolve. And one more thing we have, if you have one circle over another circle, and if you revolve this circle over another circle, then you will get epicyclic gear train, sorry, epicycloidal profile, yes or no? Epicycloidal. And similarly, if you revolve one wheel inside the other wheel, then you will get hypocycloid, hypercycloid, yeah, sorry, this is hypocycloid, yes or no? And by using both the things, we can make a cycloidal profile. And if I talk about little bit about cycloidal profile, then you can say in the cycloidal profile, there is no base circle first, and everywhere we have interference free zone, yes or no? साइक्लोइडल प्रोफाइल में कभी भी इंटरफेरेंस नहीं होता, बट हियर वी हैव वन डिमेरिट. First one, that is it is difficult to manufacture. Second point, by changing the center distance, the pressure angle will also change, and even during the engagement and disengagement, pressure angle always varying, yes or no? And the third, it doesn't have any vibration absorbing capacity, yes or no? So these are the three main demerit of the cycloidal profile. That's why it is not used for making gear, yes or no? When we talk about involute gear, so actually in involute gear is a very simple to manufacture, but it has some interference zone between the dedendum and base circle, yes or no? Correct. So and one more thing, in this the pressure angle is remain constant while operation, yes or no? So these are the two main advantage. It is easily manufactured, and here we have pressure angle, constant pressure angle approximately, and it also has very good vibration absorbing capacity. That's why generally we use involute gear profile for making gears, yes or no? For making gears, yes or no? Is it clear? So you can see last question. The mercury does not wet the glass tube. This is due to the property of liquid known as. Mercury glass tube को wet क्यों नहीं करता? Why? Because it has very huge cohesive force. Cohesive force means force between similar particle. Force between similar particle. Yes or no? And another point, that is where it also it also have very good surface tension. That's why it makes an spherical shape, yes or no? So the correct answer is surface tension. Is it clear? So this is all about all 85 question in single go, correct, of previous HPCL exam. कौन सा exam? HPCL 2021 shift 1 question paper. Is it clear? Correct. So once again, dear students, I am telling you one thing. Your PDA team provides you a specific module for this exam, HPCL exam, and since last 3 years, we continuously provide exclusive module for this exam. Yes or no? And this is our third turn. So definitely many students get benefited with this program. Yes or no? And in this module, we provide you a live session as well as recorded lectures, correct? So here we see continuous practice session as well as a little bit theoretical concept also, and the whole recorded lecture for complete theoretical knowledge, yes or no? And along with this, we also provide you test series, 5 full length test series and a 20 part test series, yes or no? 20 part test, is it clear? So this is again one of the very big advantage, very big thing. And another one, along with this model, we also provide you a interview session, correct, training interview, that is it includes interview as well as GD and PI, yes or no? Correct. So if you're planning for this exam, then definitely you will join this module, and definitely this module will help you a lot. And once again, thanks for watching, and keep preparation continue, correct? So thank you.